Is it the second last one?
It is the second last.
Second last one. So I went through the poster, the flyer, and I came across a number of interesting topics. But more than the topics, it is pertinent to know the background of the participants. Only then something beneficial, something that can be utilized, can be delivered. So at the outset, let me share a link with you, and I request you to just respond to the query there. The question is, what is your background? So you need to just write whether it is computer science or electronics or physics or whatever. I assume that there is a varied background of the audience there. So please just let me know about your background. So the link is shared. Sorry, I beg your pardon. I shared the meeting link. I'll share another link very soon. Yes. Yes, this one is the correct link, the answer garden link. Please click on this link and just write your background, your field, nothing else. That's it. After that, we'll start. Okay, as you can see that there is nothing on the screen. That means no one has clicked on that link and provided their background. It also lets me know that the participants are active or passive. Other than the background, I would have known whether you are there, you are present in the session, or you have just logged in and left. So still I don't see any responses yet. It's simple, just write your background. For example, you write physics and it will show up there. I think my screen is visible to all of you, right? I've shared everything.
Yes, sir.
Okay. See, for example, I just wrote computer science and it's showing up as computer science there. I think there is some background noise. I request you to mute your microphone. Jyoti ma'am, can you please turn off your microphone? I request the host to mute the participant from where the noise is coming. Okay, thank you. So I still see that there is no response there. Anyway, it means I have to just run through my PPTs and over. Okay. Let's proceed then. So the topic of today's session is data to insights, leveraging analytics for competitive advantage. I'll begin with A quote by Carly Fiorina. She was a CEO of HP. She says, the goal is to turn data into information and information into insight. I think it will be difficult to go ahead like this because there is some noise coming still. Can the host please mute the participant from where this voice is coming? Okay, thank you. Or you can make me co-host, then I can take the action from my side. I won't have to request you. I'll just mute if there is some disturbance from anyone. I know it happens, and inadvertently it happens at times. So you need to fix it. Okay, thank you. So she says the goal is to turn data into information and information into insight. What is data? The values, any values, like the number that you have, 1, 2, 5, 8, 6. If I present you with a set of numbers, say 6, 5, 5.5, 5.75, and so on, then you cannot make out what it means. But if I tell you that these are the numbers representing the heights of different students of the class, then that would make sense. That data will become information. When there is some raw fact, some set of numbers, values, quantities that you don't know anything about, that is data. But if there is a context to it that makes sense, that becomes information. Data can be of various different types that we'll soon learn. It can be like textual data, it can be numeric data, it can be anything like yes or no. So that is also data. But depending on the context, the question, the response, then that data will make sense and that will become information. And more importantly, that information needs to be converted into insight. Insight is what you infer from that information and take action accordingly. So definitions won't help much. I'll give you an example to explain what data, information, and insight mean. Can you see this picture over there? What is written in the picture, in the image? Anyone looking at the image and getting confused why it is there? Oh, great. Okay, so this shows Bata. Bata is a shoemaker. There is a story associated with this shoemaking company. At the end of 19th century, just as the colonial Africa was opening up as a market, all the manufacturers of shoes in the Victorian England sent their representatives to Africa to see if there might be an opportunity there for their wares. All duly came back and they had the same answer. They said, nobody in Africa wears shoes. That was the condition back then. They didn't wear shoes. So they came up with the answer that nobody wears shoes. And then they inferred and they said, because there is no market there, they don't wear any shoes, we should not go out there. There is no market for our products. So what we see here is the data is what you survey. For example, do they wear shoes? Yes or no. The answers, yes and no, this constitute data. And in context, this answer is for wearing shoes. Now it becomes information. This is about shoes. They don't wear shoes. This makes sense. This is a meaningful data, which is an information now. And then that information turns into an insight. So the representatives who went there, they inferred that because nobody wears shoes there, we don't have a market. So that was one set of inference. That was one of the insights. However, the insights can vary. So these are the representatives who said that we don't have any market there because nobody wears shoes. Except the representative from Bata. He came back from Africa, from colonial Africa, in the back then in Victorian England, and he said nobody in Africa wears shoes, so there's a huge market for our products in Africa. So look at the mindset. So this changed the entire thought, the entire observation. So the insight changed. This guy, he thinks that they don't wear shoes over there. So if we make them wear shoes, if we ask them to wear it, explaining the advantages of wearing shoes, if we can convince them, then we'll have a monopoly over there. There is no competition. It will be an enormous market that we should explore. And the rest is history. That's why these signs promoting Bata appear all over Africa, even in the remotest of spots. And then Bata has become a formal shoemaker of Africa. So they are known as the shoes of Africa. So this shows the difference between the data, the information, and the insight. And the insights, as you have seen, can vary. Let me give you another example. Just because you observed something, you should not jump to conclusions. Rather, you should look into various different aspects. For example, the other representatives from other shoemakers, they just jump to conclusion that because they don't wear shoes, we don't have a market. However, the Bata representative thought differently, and he just captured all the market because of that consideration that, okay, they don't wear shoes, but we can make them. Similarly, let me give you another example. There is a study that shows that ice cream sales are correlated with shark attacks. Now, does this mean that next time you grab a scoop of ice cream, you should pack your shark cage? Of course not. It is just that both happen more often in the summer. You eat ice cream in the summer, and the shark attacks increase in summer. So just because things are correlated, it doesn't necessarily establish a causal relationship. Correlation is not causation. So you should know the difference between correlation and causation. So everything that you get from the market in the form of market research or information, you should just pause, take a look at it from different angles, and then draw the insight. And you should not immediately jump to conclusion based on what may be apparent to the eyes, but there can be more to it. Okay, now let's move formally to data analytics. So as we know, by the way, before we discuss analytics, can somebody tell me the difference between analysis and analytics? These are two terms very closely related yet different. There is a term called data analysis, and there is another term called data analytics. Can anyone explain the difference to me? Let me tell it. Analysis is about what has happened in the past. It talks about past. And analytics is about future. Based on what has happened, you predict or you prescribe what should happen. So that is analytics. However, the analysis part is also covered in the analytics. They just describe it as descriptive analytics. But in a sense, that is analysis, and analytics is about future. So if we talk about past, it is analysis, and if we talk about future, it is analytics. So this is how analytics is defined. It is the use of data, information technology, statistical analysis, quantitative methods, and mathematical or computer-based models to help managers gain improved insight about their business operations and make better fact-based decisions. Data, you know very well, is raw facts. Information technology is the technology that uses information. We have so many information and ICT tools that we use in our daily life. This statistical analysis involves statistical tools, and quantitative methods means the methods that involve quantifying the data rather than just saying vague fuzzy terms like good or bad. Instead, you have the values, you have the numbers. In mathematical or computer-based models, there are different types of models. For example, for decision making, you have the decision models. So you can linguistically write down everything, but it's more appropriate to represent them with the help of some kind of a mathematical equation formula. So those models are mathematical or computer-based models. We'll have a look at the introductory example of decision models in the upcoming slides. So the objective is to help the managers gain improved insight about their business. Therefore, because it is primarily meant for the enterprise, the business, the institutions, so many a times a similar term. Yes, you can come up with some differences, but basically the core remains the same. A similar term can be used in place of data analytics. They call it business analytics. So essentially, they do the same thing. Here are some of the applications of analytics. For example, in the field of management of customer relationships, in financial and marketing activities, in supply chain management, in human resource planning, pricing decisions, and in sport and game strategies. Let's take one of these, for example. Look at the sport team game strategies. So there was a time when data analytics was not so popular. So the players used to practice their games and then go to the match day and play. And then gradually, as the data analytics field developed, now data analysts are there in the support staff to look at various different aspects of the game. For example, the strengths of the different opponent players, their weaknesses. Let's take the example of cricket. So a player is good at playing spin or bad at playing baseballing or something like that can be inferred based on data. For example, how many balls were bowled to him and how many runs did he make on a particular type of bowling, for example, off spin bowling or leg spin bowling or medium pace bowling. And then accordingly, you can target the player's weakness. And then the moment he comes onto the crease, you can introduce a bowler who can immediately take advantage of the weakness of the. So, and there are various different facets to it. This is just an example. So, game strategies has completely changed. It's not merely about practicing and putting those practice into the field of play. Rather, they strategize based on the data, the information that they have. There is a strong relationship of analytics with the profitability of business, the revenue of business, and the shareholder return. Enhances understanding of data, is vital for business to remain competitive, and it enables creation of informative reports. Now let's discuss some of the types of analytics. So uh, primarily they have three different types, even though they can add more. Different authors and different practitioners, they describe the types differently. But primarily these three types are there. First is descriptive analytics. As I already explained a bit earlier, that the analysis part is called descriptive analysis. Descriptive analytics. Analysis means something about past. So descriptive analytics deals with what has happened already. So, for example, let's say there is an analytics about your data usage or the time spent on YouTube. YouTube presents some analytics. They tell you that in the past week, you have spent this much hours watching some videos on the YouTube. They tell you that you spend roughly 2 hours a day on YouTube, or you spend maybe 3 hours a day on YouTube. So these are things that constitute descriptive analytics. And predictive analytics is about what could happen in future. Of course, it is also based on what has happened in the past. So the trend will be analyzed, and accordingly, some relationship will be developed in the data that you have. And then based on that, for example, if you generate a graph, so you'll extend it and you'll try to predict what will happen in the future. This may not always be accurate, but over time they have developed different mechanisms to increase accuracy, and many a times they can come up with as accurate prediction as 99%, 98%. So that's perfectly reliable. So descriptive analytics is about past, and predictive analytics is about the future. And prescriptive analytics, as the name suggests, prescribes what should be done based on what has already happened or what could happen. The analytics software that you develop, it will suggest the managers or the users what they should do. For example, if they're focusing on the profitability of the business, or if they're focusing on increasing the sales, so how to do that. So this kind of analytics will suggest the steps, the measures that should be taken. For example, the pricing of a product. So prescriptive analytics can suggest, okay, this is the festive season, so you can price this product accordingly, and this is the appropriate price for this product. So these are the different types of analytics: descriptive, the predictive, and the prescriptive analytics. Let's see how it is applied in practice. Tara's Entertainment, this is an America-based, US-based entertainment company. It owns numerous hotels and casinos. So it uses analytics to forecast the demand for rooms. With the help of analytics, it predicts, okay, in this time of the season, in this month, or in these dates, this will be the demand. And it also checks the segment customers by gaming. It segments the customers by gaming activities. Like these kind of customers are likely to purchase these services, and those kind of customers are likely to purchase those kind of activities, because they own casinos, so they have different types of gaming activities, different types of games. So the users participate in them, so they can segment them. They can classify, okay, these kinds of users should be targeted for these kinds of activities. And then using prescriptive analytics, they can set the room rates, they can allocate the rooms, and they can offer perks and rewards or discounts to customers. So this is how the predictive analytics and prescriptive analytics comes based on the descriptive analytics. So it's all centered around data. So let's look a bit deeper into what data is and what are different types of data. The data is simple collection of facts and figures. And database, those who are from computing background will know, it's a collection of computer files containing data. You can use the database management system to maneuver this data. You can insert new data, you can modify the existing data, you can change the data, you can update it, you can delete it. Different types of actions are possible with the help of the database management system that we know in short as DBMS. So database is a data file, and information comes from analyzing this data. Merely presenting the facts and figures won't help. There should be a context to it, meaning to it. So you should analyze it to draw information from it. Here are some of the examples of data in business. You have annual reports, the accounting audits, the financial profitability analysis, the economic trends, the marketing research, the operations management performance, and the human resource measurements. These are some terms associated with the quantification of different types of data. So metrics, as you know, metrics are used to quantify performance. Like say, for example, if you wish to identify the tall students of your class and the short students of your class, there should be some kind of a metric, a scale that you will use to measure the height. So that scale is, let's say, for example, you have meter or feet or any other metric that you will use. And measures are the numerical values. For example, if you get a value, say 6 feet and 2 inches, so that is the height of one of the students. So that is the measure, that is the exact value. Data can be discrete or continuous. Discrete is like, for example, if you collect or gather some data that answers a question in maybe yes or no, or it's binary in nature, like some deliveries on time or not on time. So that is discrete data, either this or that, or so there is no continuation to it. The number, some crude numbers, like number of proportion of on-time deliveries, etc. However, the continuous metrics are measured on a continuum. For example, you have the delivery time. If you plot the different delivery times of different products or different customers, you will have various different types of times, ranging from a few hours to a few days to a few weeks to even months, or even more than that. So this can be anything. So we call it continuous data. Similarly, package weight can vary. It can be a few grams to a few kilograms, or maybe even a few hundred kilograms. Similarly, purchase price of different products vary, and they can have any value. So this is also continuous. On the basis of measurement scale, data can be classified into 4 different categories. One is known as nominal data or categorical data. The other is ordinal data. Then you have internal data. And then there is ratio data. I'll explain what these different types of data mean along with some examples so that it becomes clear to all of you. Let's focus on categorical or nominal data. Nominal means related to names. So these are the data placed in categories according to a specified characteristic. Categories bear no quantitative relationship to, for example, a customer's location. So this is a nominal data. Customer's name, this is a nominal data. Categorical data. Employee classification, whether he's a manager or a supervisor or an associate. So these are categorical data. At times, even numbers may represent nominal data. You may think numbers as numeric data. For example, look at the sports persons. Sports persons, when they are on the field, they wear jerseys, and on those jerseys they have certain numbers. But those numbers do not necessarily represent their rank or position. Rather, that is just to identify them. So that is, in a sense, not a number, rather a name. So if a sports person's jersey says 99 or 1 or 100, it is not relative to one another. Rather, it is different values. So you can say that this is also categorical or nominal data. However, if those numbers represent some kind of value, relative value, then it will change. It will not be a nominal data anymore. Then we have ordinal data. So ordinal data is ranked or ordered according to some relationship with one another. There is no fixed unit of measurement. For example, college football rankings, or even the class students rankings. Maybe this time around, the one who holds rank 1 got 95% marks, but in the next year, the one who comes first, who stands first, he has just 85% marks. So this has no relation to some kind of an absolute value. But yes, relatively, it is ordered. The one who gets the highest marks, irrespective of whatever that mark is, that guy will get the first rank. Similarly, the one who plays well, of course, there are different parameters. On the basis of those parameters, you will be ranked. So your football rankings, athletic rankings, your volleyball rankings will depend on that. But rankings are ordered according to some kind of a relationship with one another. Like rank 1 is better than rank 2 is better than rank 3, and so on. Similarly, you can have some survey responses like poor, average, good, very good, excellent. Again, they have some kind of a relationship. And there is some order. Like poor is the worst, then comes average, then good, then very good, then excellent is the best value. So this is ordinal data. Next is interval data. Interval data is, in a sense, ordinal data, but with constant differences between observations and no true 0 point. What do you mean by constant difference between observations? Like, say, temperature readings. So you have these readings in Fahrenheit or in Celsius. So there is a constant difference between observations. Like you have temperature of 97 degree Fahrenheit or 98 degrees or 99 degrees. On the scale, there is a constant difference of 1 degree between first value to second value and third value. But there is no true 0. It is 0 point. The actual 0 value, if 0 represents the absence of something, then that is true 0. But if 0 doesn't represent the absence of something, then that is not a true 0. 0 degree Fahrenheit or Celsius doesn't represent the absence of temperature. No, there is some temperature there. On your scale, it is 0. Temperature can be negative as well. Temperature can be positive as well. So there is no true 0. However, the interval is fixed. There is a fixed interval of, say, 1 Fahrenheit every time or 1 degree every time. So it is called interval. Here, the ratios are not meaningful. The examples are temperature readings, SAT scores, etc. Next comes the ratio data. So ratio data are continuous values, and they have a natural 0 point. Ratios, of course, are meaningful. For example, the monthly sales. You can compare the sales in the month of November, the sales in the month of December. So you see that there is some kind of meaningful ratio. These sales can be compared. Like suppose you can come up with some values like they have sold twice as many units as they sold in the last month. So this 2:1 is the meaningful ratio. Similarly, the delivery times. How fast your delivery has become compared to how it used to be a few months back, this can be calculated. So these ratios are meaningful. In that case, we call the data as ratio data. In mind that there can be a data which may fall into more than one category. It's not fixed that it will only be ratio or only be nominal. There can be some data which may belong to one or more categories. I talked about the decision models in the beginning, so let's have a look at some decision models too. Without going in the cumbersome theoretical details, let's have an example. Very simply, mathematics or total cost. When you are producing something, when you are selling something, so you look at the cost that is incurred. So the total cost is calculated by the formula. And this formula, a very simple formula. It may not always be the same. You can have various different types of parameters in it. You have different variables. You can include all those and make it a more realistic equation. But to keep it simple, it's F plus VQ, where F represents the fixed cost, and V is the variable unit cost, and Q is the quantity produced. So, for example, let's say you are producing 1 unit of a product. So there will be some absolute fixed cost that will not change, like the initial setup, say it costs some maybe $50,000. So that will be there. Plus, additionally, now for every quantity produced, you will have some kind of a variable cost like $2, $3, $50, $100, whatever. You will multiply that with the number of quantities that you're producing, and then finally add it up with the fixed cost, and then that will give you the total cost. So as you can see in this diagram, you have a unit variable cost and you have the quantity produced. Now they get multiplied, and the variable cost gets it is found out, and then it is added with the fixed cost, and then the total cost is found out. So let's take an example. So suppose we want to make a decision regarding the dilemma of manufacturing and outsourcing. Suppose you need to supply some product to some company. So either you manufacture it at your place or you outsource it. So what should be your aim? Your aim should be to maximize the profits. And to maximize the profits, you should minimize the costs. So if outsourcing is less costly, you should go for outsourcing. And if manufacturing is less costly, you should go for manufacturing. So let's calculate what happens in case of manufacturing. Look at the equation that we have before. Total cost is the fixed cost plus variable cost. So using this formula, the fixed cost plus variable cost formula, F plus VQ, say $50,000 is the fixed cost, and then the variable cost is $125 per unit. Now you need to find the break-even point. That means a point up to which the manufacturing is less costly, or maybe outsourcing is less costly, and beyond that, the other thing. In case of manufacturing, beyond that, it will be outsourcing. In case of outsourcing, beyond that, it will be manufacturing. So then you will be in a position to make a decision regarding whether you should go for manufacturing or you should go for outsourcing. So suppose you produce n units of a particular product, say 1,000 units, 2,000 units, 100 units, 500 units, whatever. So what you'll do is you'll add $50,000 to 125 into that value, and can be anything, say 500, and then you'll check if the manufacturing cost is more than the outsourcing cost. Outsourcing cost is 175 into that value. So if you perform this calculation, you will come to know whether you should go for manufacturing or you should go for outsourcing. So you can, in Excel or in any other tool, you can just draw these graph, these plots that will help you identify the break-even point and the break-even volume, and therefore it is also known as break-even analysis. And then you can make a decision for the quantities below that volume or above that volume. So now, before we proceed further, let's have a look at one of the case studies. The case studies is of Asian Paints. You might be wondering why I'm talking about Asian Paints when we are talking about data analytics. So, in fact, they say that Asian Paints is the biggest data science company that is selling paints. So that's the paradox. But to be very honest, they had this insight. They wanted to make use of data much before others. The founder of Asian Paints, Champaklal Choksi, I guess it was his name. So he was the first person in India to buy a supercomputer back then in around 1970s. So he bought it for rupees 8 crore, which equates to around 1 million now. So he invested that much amount, and people thought like he's mad. But the reason why he did it was to gather data, collect data, and then process the information and then make decisions according to the data insights that he gets. And that has resulted in the growth of his company, Manifolds. And now, Asian Paints is twice as big as all other competitors combined. And it has given around 20% profit continuously for the last 6 years. So let's have a look at a couple of small videos that tells you the story of this Asian Paints. Just a minute. Take out the microphone so that it becomes on. Okay, so this was one of the short videos that I had to play to explain how Asian Paint works. But this is what Asian Paint has achieved, and how it has achieved it is explained in this video. We play this. Hardly 5 minute video. Okay, so let's come back after these short clips that explain these clips show how Asian Paints became the largest paint seller in the country. It's not because of the quality of their paint or any other business strategy other than leveraging the power of data science and data analytics. They collect much more data than others and they process those data more efficiently, and they have a system in place that makes sure that nobody comes even closer. So moving forward, now let's come back to decision making that we were talking about. So irrespective of your field, whether you are from computer science or any other branch, you can understand it with the help of examples. I'll try to keep it simple. There are different methods of decision making that you can employ. Let's take this example at hand. Say you as a businessman want to invest your money and you have two, three different options. So you will have a look at those options, you will perform some kind of analysis, and then you will take some decision. So the options that you have at hand are either you invest in an apartment building where people live, like you have apartments in residential areas. They are not meant for commercial purposes. You don't build offices there. People live there in residential colonies. Or the alternative option is you invest in office building. Office building is a corporate place where any company or business or firm or organization can have their office. Or you can invest in a warehouse. Many companies or manufacturers or sellers, they make use of the warehouses to store their stuff. Say, for example, there is a spice making company that sells Indian spices across the globe. Say, chili, coriander, turmeric, and similar things. So it will require a big warehouse to store a lot of these spices and the raw materials, maybe raw turmeric, raw chili, raw pepper, etc., in a cold storage that has temperature in the negative. So you can invest in a warehouse. Warehouses are also employed by different firms and organizations and companies. Now, whether you should go for an apartment building or an office building or a warehouse is a decision-making problem. So how you solve it? Again, there is an element, a human element to it. We have different mindsets, just like we have seen in the example of colonial Africa, where people didn't wear shoes. Bata representative had diametrically opposite mindset as compared to the other representatives from other shoemaking companies. Therefore, he made a decision that was different to the decision made by others. However, the data that was available to them was the same. The information that was given to them was the same. The insight varied depending on the person having a look at it. Now, there are two possibilities. One, when the economic conditions will remain good, and the other, when poor economic conditions will prevail. There have been instances in the past when the economic conditions are not so good, and there have been instances in the past where there is economic boom, like COVID uh, disrupted a lot of industries and even supported a few. Before that, you had the Great Depression, as it is famously known as, or in the recent memory, you can have the economic meltdown. You can look at the economic meltdown triggered by the fall of Lehman Brothers, the bankers from US. A lot of bankers, they went bankrupt, and because many IT firms had the projects from those banking and finance institutions, so it heavily impacted them as well. And in this era of globalization, different industries, different companies, they have these links and connections that do affect one another. So that resulted in a deep economic crisis. So economic conditions are not always good. So you have the three options, whether to invest in an apartment building or an office building or a warehouse. And depending on the prevailing economic conditions, the payoff that you'll get is mentioned in this table. If the economic conditions remain good, then the apartment building will pay you $50,000, the office building $100,000, a warehouse $30,000. On the contrary, if the conditions change and there is poor economic conditions prevailing, in that case, the apartment building will not give you more than $30,000, and the office building will pay you minus 40,000. Why is minus there? It means because of the maintenance issues of the office, maybe you have some fixed expenses every month going on there. So nobody is hiring the place. So you may end up spending from your pocket and getting nothing in return. So that is negative payoff. So you may get a negative payoff from office building or a very small payoff from warehouse. If the economic conditions are not good, then of course the manufacturing and supplies may get affected. So they might not need a lot of warehouses. So the demands will go down, and accordingly the payoff comes down. So it's around 10,000. So how will you choose? You have the data in front of you, you have the information. So predicting the future, there can be good economic conditions, there can be poor economic conditions. You will either invest in an apartment building or an office building or a warehouse. There are different strategies and approaches. One is known as the Maximax approach. Maximax is the shortcut for maximum of the maximum. So you will get the maximum payoff in good economic conditions or poor economic conditions. But naturally, you'll get it in good economic conditions. So in Maximax approach, the decision maker selects the decision that will result in the maximum of maximum payoffs, which is an optimistic criterion. So maximum payoffs that you can get in case of apartment building or office building or warehouse will be when the good economic conditions prevail. So now you look at the column for maximum payoffs, meaning the column representing good economic conditions, and you forget about the poor economic conditions. So that is the optimistic approach. You are looking at the market with an optimistic thought. Okay, the market will remain good, so you get these payoffs. So out of these three, office building has the maximum payoff of $100,000. So instead of going for apartment building or warehouse, you predict that good economic conditions will prevail. That means if you go for the optimistic approach, you will choose an office building over an apartment or warehouse. And if what you hope for comes true, then it will pay off $100,000. However, this is not always the case. And depending on your mindset or the market forecasts, you can opt for the maximin approach. What is maximin? Maximin criteria uh, tells the decision maker to select the decision that will reflect the maximum of the minimum payoffs. It is pessimistic criteria. Don't get confused. Maximum of the minimum payoffs means for the maximum payoffs, we looked at the column of good economic conditions. For the minimum payoffs, of course, the payoffs will be minimum when the poor economic conditions prevail rather than good economic conditions. So, in case of poor economic conditions, you have lesser payoff values for apartment building, office building, as well as warehouse. For apartment building, you have only 30,000. For office building, you have a negative payoff. Warehouse, you have 10,000. So, if the economic conditions are not so good, uh, you will try to maximize whatever is available. So, out of these three, apartment building will give you the maximum payoff, that is 30,000. So, in maximum criteria, you will go for the apartment building rather than opting for an office building or a warehouse. So this is how you make a decision by maximax or maximin approach. There are other approaches as well. For example, there is Purvish approach. This criteria is a compromise between the maximax and the maximin criteria. There is a coefficient of optimism, alpha, which is measured, which is a measure of the decision maker's optimism. And of course, the pessimism can be calculated, or the worst payoff is probability in terms of probability. If you have maybe a positive probability as 0.8, the negative probability will be 0.2, 1 minus 0.8. So the probability of just like heads and tails. So if you have 0.5 probability for heads, then 1 minus 0.5 for tails. So if the coefficient of optimism alpha has a particular value, so 1 minus alpha will apply to the other. So let's perform these calculations. The apartment will, in this case, the coefficient of optimism, say, is 0.4. So the person, the businessman, the investor is not too optimistic, but little bit he is. So, and 0.6 is 1 minus alpha is 0.6. So for the good market conditions, good economic conditions, you will consider the coefficient of optimism, and for bad economic conditions, poor economic conditions, you will subtract that with 1. So you multiply $50,000 with alpha, which is 0.4, $30,000 with 1 minus alpha, which is 0.6, and you get $38,000. Similarly, for all other values, like for office building, for warehouse, you apply the same $100,000 into the coefficient of optimism, alpha, which is 0.4, and you then add minus $40,000 into 1 minus alpha, which is 0.6, you get 16. Similarly, for warehouse, you calculate it and you get it as 18,000. So now, out of these three, when you have a balanced approach, you have a coefficient of optimism, and then you consider that, and that means if you make it probabilistic, you are thinking like, okay, there are 40% chance of market conditions, economic conditions being good, and 60% chance of the economic conditions not being. So you are taking a balanced approach. You are multiplying those probabilities. Of course, these are not probabilities. These are the coefficient of optimism or pessimism, respectively. So probability can be determined by various different methods, and in probabilistic methods, instead of these coefficients, you'll just multiply with the probability. So we are not considering probability over here. It is just a coefficient of optimism. So you multiply and you get these values. So out of these, you see that the apartment building is the safest one. It will give you the maximum payoff. So you can go for apartment building if you apply the Hurwitz criteria. Similar to it, you have the Laplace criteria, which is also known as the equal likelihood criteria. So this criterion multiplies the decision payoff for each state of nature by an equal weight, thus assuming that the states of nature are equally likely to occur. States of nature, as we had, were the good economic conditions or the poor economic conditions. So in case of good economic conditions, you have this likelihood value as 0.5, and in case of poor economic conditions, again you have the likelihood value as 0.5. So you have equal likelihood of both. Either this may happen or that may happen, and then you multiply these values. So you get apartment building payoff. It comes around $40,000 because you multiplied 50,000 with 0.5 and 30,000 with 0.5. You can revisit the table, you can check the values. This is 50,000, this is 30,000, and so on. So you made these calculations. For office building, you get 30,000. For warehouse, you get around $20,000. So that is the equal likelihood or Laplace building. So these are, and again, because of these values, these outcomes, these outputs that you get out of 40,000, 30,000, 20,000, of course, 40,000 is the highest. So you may tend to opt for apartment building in place of office building in warehouse. So you can see that in these four approaches, have a look at this. See, Maximax approach tells you to go for office building. Maximin tells you to go for apartment building. Then Hurwitz tells you to go for apartment building. And then equal likelihood also tells you to go for apartment building. So if you take the verdict based on the number of different approaches, so out of these four approaches, you see that three approaches suggest you to go for apartment building, while the fourth one tells you to go for the office building. Now, you may take some risk, then go for office building in order to gain more reward in good economic conditions, or you may play safe and go for apartment building that will pay you decently, irrespective of the economic conditions. So instead of subjective random decision making, now you have objective ways of making the decisions. So data analytics influences either positively or negatively your decisions. You have the quantities with you. You have the reasons to make a decision. And then based on those valid reasons, mathematically calculated values, you take a management decision, you devise a policy, etc. Some people might say that if the data is incomplete or there are some inaccuracies in the data, of course it cannot always be perfect, then the prediction or the analytics will also not be up to the mark. So should we go for data analytics even in that case? What should be the answer? Yes or no? Some people may say, no, you should not go for data analytics. Rather, you should think yourself and then make a decision rather than going for any established data analytics model. But experts suggest that even if data is incomplete or not up to the mark, you should still go for data analytics to support your decisions, because guessing without having any data or any value will be worse than making an informed guess, even if that is based on incomplete value. that should ideally be better than a guess that doesn't have any support of data at all. You should still go for, of course, you should strive to have the clean data, the complete data, you should have the perfect data for these data analytics operations. However, even if you don't have that perfect data, you should still go for data because that is a quantitative, objective approach. So that should always be preferred over a subjective approach. So with that, I'll stop it here. If you have any questions, feel free to ask. I had planned not many things in between, but because there is passive participation of the participants, I could not do that. Even I could not get the responses from the participants, like which background they are coming from. So nobody responded to any question or anything like that. So I had to just run through the slides. So now I think whatever I had to offer in this session is over now. So if you have any questions, feel free to ask. So if there is a possibility that everything is very clear to you, so there are no questions, but maybe nobody listened to what was presented in the session, so you don't have any questions. In either case, my pleasure talking to you. May I now request the organizers to let me know whether I should stop and leave the session.
Sir?
Yes, ma'am.
Okay. Good afternoon, sir. Thank you, sir. Thank you for your wonderful session, sir.
Okay, thank you. So,
Sir,
may I
if
take up?
we know, sir, your voice is breaking, sir.
Okay, I have asked the participants if they have any questions they may ask, but I think nobody is interested in asking any questions. So may I leave now?
Okay, sir. Shall we wind up the class session, sir?
Okay.
Thank you so much, sir.
Hello? Hello?
Yes, ma'am.
Feedback is not posted here.
We will send you through mail or if not, ma'am.
You'll send it to a mail ID or